You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Hey guys, so she who shall not be named
has been named.
Yes. And by that we mean we've been given permission to share her name on the air to help promote her first book. Soulbound by Bethany Adams is now on shelves and Amazon, available for purchase. If you're like us and enjoy a good fantasy novel, and really, we've been reading Bethany's stories for many years.
Yeah, since college at this point? So, well, for me, it's been since college, and you knew her before then. So,
yeah. No.
And this is a huge milestone for her.
It really is.
Really happy to see this.
To honor her first book, we are holding a contest to give away an autographed copy of the book to one of our listeners. To enter the contest, go to iTunes, or you can go to our link, www.completedeveloperpodcast.com/iTunes, and leave us a 5-star review. We'll put all the names of the reviewers in a hat or a sorting program and draw a winner to be announced the first week of July. Welcome to another episode of Complete Developer Podcast. This week we are talking about creational design patterns. These are the factory method, the singleton, prototype, builder, object pool, and the abstract factory. Before we get started, though, Will, what have you been fighting this week?
Two things at once. Well, two technical things and then other stuff on the side. The technical things at the moment are Amazon EC2 and database migration strategies. So at work, I was trying to deploy a project to our Amazon EC2 server. Turns out the server didn't have WebSockets turned on, which that thing has to have. Updates have been turned off on the box, which is also problematic, and we won't get into that. But so we turned it back on. And then it sat there for 4 hours saying, Windows is getting ready. And it's still spinning probably right now. I'm going to remote into my box from the house, and then I can remote into that one and see what I saw.
Sounds like a Rube Goldberg machine there.
Yeah, well, it works. So yeah, that's going on. Well, since I didn't want to sit there and watch the little spinny thing, because that's pretty boring pretty quickly. I know that we're working on a continuous integration, continuous deployment pipeline. And one of the things that we have to have for that is database migration, so that we can have the separate environments and we can move stuff between them. And so I started looking into tools for doing that. And the problem with our database structure is we have at least 2 databases, often more. And those databases have synonyms that point at each other. So like database A has a synonym that points at something in database B, which has a view under it that it's calling that points at a synonym back in database A. And so you have cycles of dependencies between 2 different databases. If you're trying to build a script for a migration for one of those databases, it will fail because you don't have the other database there and it can't create the synonyms. So just trying to figure out what a strategy even looks like for that kind of migration is what I spent most of the afternoon doing while this other crap was going on. And the other thing is like I've been really, really stressed for like, I don't know, about 3 weeks, I guess. You still grinding your teeth? Yeah, like I've been having that jaw pain. It's not been as bad, but I mean, it's just like, good grief, what am I, the thing is my workload has dropped off quite
That's what
a bit.
It is.
And it's like the worst time for me is after the stuff that should be stressing me out. And I was completely, really just not very prepared for that. And so it caught me by surprise. Like we went to Vegas, and that's when my neck started hurting and my back started hurting. Now, part of that was, the seating on Southwest too, which is, pretty much a human compression algorithm. So yeah, that didn't help, but yeah, I'm fighting that. I'm having a lot of headaches, a lot of stress, just a lot of, just general fatigue and irritation at people.
More than normal.
Yeah, more than normal. And I really do think that's because the workload has dropped off, and it's sort of like now my psyche can go, hey, let's let's vent spleen over this right now.
Or let's now you can deal with all these things that you've just been able to go, you know what, I'm too busy to care about this right now.
Yeah. So how about you?
Well, first off, I think that made a noise.
Yeah, you're lucky getting to drink beer. I'm also doing low carb right now, which is part of the reason I'm cranky.
Well, yeah, he doesn't have a beer on him, so
I'm drinking water.
Yes, that's
like it's the Dark Ages.
Yes, it's odd. Well, I have made another Linux convert. Our friend Jason, the one that lives close to us, I went over to his place yesterday. He was frustrated because, I guess, Friday night he had turned his computer off, gone to bed, and when he woke up Saturday morning, it wouldn't boot. And it was giving him this blue screen, and I think it was like error, lots of zeros, 225. And
I think that's a video card thing. I think I've actually seen that. It's not
a video card thing. No, it's basically it's some file in the boot, like one of the first boot files.
It's corrupted boot files, yeah. Because I know I've seen that before.
It's not just the boot files. It's his whole hard drive. Like, I got in and was able to get into a command prompt, and I couldn't even find the hard drive. Yeah. Or at least that partition. And so I made him a Linux boot disk that he can at least get on and get on the internet. And most of what he does is Facebook and chats and stuff like that.
He's not storing files on his disk anyway.
No, he has an external drive that he can use for that. So
until that one fails.
Well, yeah, but we're going to get him a new hard drive. But anyways, he texted me today and said that he really enjoys using Linux. He's just frustrated because he can't play MP3s. And I said, well, you will be able to once we install it, but because
you should be able to do that off it depends on what distro you get, because some of them actually include the non-free software.
Yeah.
Like your NVIDIA drivers and your MP3 players and
yeah, I didn't include that. But got that going on. Also on the Linux conversion front, my mother told me today, actually, we got together for breakfast this morning, and she informed me that she wants me to completely remove Windows from her laptop because she doesn't even use it anymore, and just put Linux on the whole thing.
Well, that's that.
Yeah. We were joking earlier about getting to the year of desktop Linux, and
yeah, I mean, I would think that she would be further back in the cohort, but then my wife, who's a school teacher, really likes OpenSUSE.
Yeah,
because she had that on her laptop for a long time until we got her a new laptop, and it came with Windows on it, and it was quick to get that up. But there's.
Well, I mean, I've already got my nieces learning with the Raspbian OS on the little computer I made for them. So, I really think that because most of the people I convert over to is using Ubuntu, I think Canonical should pay me to be a Linux evangelist.
Might as well.
No.
It's, I mean, I think everybody that uses it successfully ends up doing that at some, actually, getting other people into it.
I mean, it's for my mom, it's perfect because her old laptop, it doesn't have all the junk that Windows has.
Yeah.
And I set it up to be exactly what she needs, and that's enough for her.
Yeah. And I mean, that's what I'm looking at for my setup as well. I mean, I'm going to be in the market for a new laptop, I think, before the end of the year.
Yeah.
And what I'm going to look for is a Linux laptop. I'm probably going to get like a System 76 or something along those lines, and get it done right, get something that's supported, that just outright works. And I probably won't do a ton of coding on it initially. I'll probably do more writing and stuff, because I found that when I travel with a laptop, I really can't code all that well anyway. When traveling, at least on the projects I have, because I have to have so many things open to see what's actually going on. If you do distributed programming, and it's not, not worthwhile for me.
I only have one extra screen at home.
Yeah. Like I've run into situations where I was out of room on my 4-monitor setup.
Yeah, I can believe that.
Because it's like I need to have 10 things open, and I'm splitting the screens, and I legitimately need half the width of the screen for everything.
No.
And that's just life.
Yeah. So with that said,
let's roll Jason's music, man.
All right, let's roll it. This week for IoTs, have something pretty cool for you guys. It is a family message board using Amazon Web Services IoT. And it's basically a family message board that's an LED matrix that displays a message sent by a mobile phone. And you send it using the AWS SNS for notification on mobile phones, and it shows up as a message on the family board that other members of the family at home can see. There's even a button you can press that will send a notification back to the person that sent it. And what's really cool is there's a detector that when someone is in front of the LED matrix, you can set that up to send a notification that the message has been read. It's a really cool little project on hackster.io. I'll include the info in the show notes. Basically, for hardware, you just need the iPhone, Raspberry Pi, RGB hat, LED matrix, an arcade button, or any kind of trigger button that you want. Alimentation mean wheel? Anyways, and an ultrasonic sensor. And the code is what?
Just like, and then a Mr. Fusion and a couple other random.
I'm not even sure what that is.
That's one of the things that always gets me when I have to read out loud. Is invariably I'll run across some word that I've read repeatedly, and I have absolutely no idea how to pronounce it.
I don't think I've alimentation mean wheel.
Alimentation, like alimentary, like eating.
I googled it and I get, what does wheel mean? Yeah, and the code is in Python, and like I said, it uses Amazon Web Services. It's kind of cool. It's in basically you send a message to the Amazon servers from your phone. Those servers send a message to the message board, and then the person that receives the message can confirm it, and it sends a notification back to your phone. Kind of neat little thing. And the instructions are here on how to set this up. Does involve some soldering, so Will, be careful if you do it.
Yeah, but, don't burn a hole in your hand. In other words.
Exactly. But
and I guess before we get into all of these, let's have a little talk about constructors. And I'm totally going off the rails on the outline here. But a constructor is a function that's used to build an object.
Yes.
Right. And it's part of that object's definition. But basically the idea is, that you can call it and you get the object back. There's a problem, however.
Okay.
Let's say that you have an object whose constructor takes 2 parameters. And you use it in 1,000 different places in your code. Well, what happens if you suddenly decide, hey, instead of 2 parameters, I need to add a third, and instead of, I want to switch it up so that I'm actually passing a structure in instead of those 2 parameters. Now, if you're in a strongly typed language, your compiler will catch this, right? And it'll do its little magic and tell you all the places you screwed up. But let's say you're doing this in JavaScript. Do you know what happens?
I can
everything
imagine.
That if the function only has 1 parameter and all the callers think it has 2, now when it gets called, it's that's not going to work. And it's not getting the type it's expecting either for that first thing, right? So that effectively what a constructor being called by your code does is it causes cohesion between that piece of code and the way that object is instantiated. Now, most of the time you can get away with this for a pretty good while especially in like a strongly typed language, because you'll get burned immediately by the compiler. But even so, you don't want to go change 10,000 places.
No.
So these creational patterns are ways to break that cohesion up in such a way that you don't have that problem.
Okay.
So that's a little sidebar. Beej was not expecting me to go on this particular explanation because I wasn't expecting it either, so I didn't have time to tell him. And all
right, so let's roll on into our creational design patterns. And just as a quick review, those are the factory method, the singleton, the prototype, the builder, object pool, and everyone's favorite, the abstract factory. So starting off with the factory method, go ahead. You were going to say something.
Okay.
About this.
Well, I guess a good way to think about a factory method is essentially it's a way of getting a group of classes back. Like, let's say you have a bunch of classes that have a common base class. I'll use an image from the .NET framework because I know it reasonably well. Considering that's my whole career. You have your image class, and then you have a bitmap class that derives from that. And then there's a few others. I forget what some of the others are because I can't think it through at the moment. But effectively you have multiple child classes that are deriving from an image class. Well, if I'm saying, hey, I want to load this file into memory and I don't care what type it is because I'm only using the base class methods anyway, then load it, figure out what type it needs to be and load it. So, hey, it's a bitmap. Load that up, hand me that back, cast as an image because, again, I don't care.
Yes, that makes sense.
And then I can do my manipulation. I can tell, other objects, hey, draw this on this graphics device context.
So it basically defines an interface for creating an object.
Well, it's not. It does define an interface for creating an object, and it also abstracts it so that you don't really have to care about the particular class being implemented. You don't care about the implementation being returned except for what's on the base.
Yeah. So what's requesting it can decide what's initiated or instantiated?
What's requesting it just says, hey, here's the stuff I have. Give me the stuff that handles this stuff.
Ah, now that makes sense.
Because you're effectively delegating to a class.
Okay.
To some other class coming back.
Yeah, and just a couple of things that I have here from looking this up was it's a virtual constructor.
Yes, you'll see that a lot of times the derived classes, they've got their own constructor that's being called by the factory method. But when you go into their constructor, they're doing some stuff and then they're either calling their base or they're calling their base first. Usually it's the base first and then they override. Yeah.
And got a kind of a non-coding example here. And this is an example of injection molding.
Yeah, so like if you had a machine, let's like your 3D printers, right? You're saying, hey, I have this file that is the structure of the thing I'm building, and I don't know what it is, and I don't care. I need this thing made because I'm a printing company. Mm-hmm. Put it in the machine, and what does the machine do? It makes a rubber duck. It makes an action figure. It makes whatever the thing is, and kicks it out the other end. And you don't care either because you're going to put it in a box. Like you need the structure, and
so in that example, the factory method would be the 3D printer.
Yes.
Okay. Yeah, that makes sense. That makes sense.
Although typically you're not going to have a thing where you're actually like handing it a plan, right? Yeah. It would be like handing it a path. It's like here's a file path for the file. I don't even know. Like I'm not loading it up into memory because I don't care. I'm pushing something in and I want a result out. I don't care what you create in the middle because that's not my problem.
Okay, yeah. Almost like the black box idea in psychology.
Yeah, it is kind of it is. Well, most of these patterns are kind of designed around black boxes. We do that. That's called abstraction.
Well, yeah.
Yeah.
All right. Next is the singleton. In this, only a single instance can exist.
And this is a pattern you do not find in nature.
Yeah, we were
trying to come up with something, anything, as an explanation for that.
And Will did not like the explanation that I have.
I mean, you're a singleton. Well, you're a single instance of Beej.
I am the Beej.
Right? But that said, you're an instance of a class that's derived. because you're also human and you're in, but basically the idea behind this is that you have a single global instance of a class that does one particular thing. And a lot of times these tend to be stateful. So if something changes, that thing will hold on to the state and other callers can get that state. And this is where your global variables come in. This is a slightly more refined global variable.
Yeah.
And I don't overly like using a lot of singletons, but sometimes it's really, really handy.
Well, I would think that it would be like using a global variable.
Yeah, it has a lot of the same problems. I know that I'm trying to think of a really good example that I've used recently. I mean, I can think of loads of examples from VB6.
No, give us one from there, because we have a mixed crowd, and nobody really probably writes much in VB6.
Yeah, I mean, think,
but the example would still apply. That's one thing that we talked about in the intro episode to design patterns is, they can be language agnostic within the object-oriented languages.
Yeah, and even then, there's not a really good sample. Although I'll tell you one that is good from JavaScript.
All right.
In the context of a page.
Okay.
Right, because treat a page like it's its own program. There is a window object.
Yes.
Now, I think you may be able to instantiate another one. I'm not sure why you would do that, but the expected scope of that is, hey, this is the window object. Like it's at the top level scope for the page. There's stuff hanging off of it. I can put something on it and I can get something off of it somewhere else.
Yeah.
It's effectively a communication channel between my two pieces, right? Which can be either good or bad because, hey, it's also sharing state. Mm-hmm. Which, if you remember the lessons from the Trickster episode, if A creates a change that, if A creates a change in B that can be observed from C, there's an effective communication channel. A singletons frequently devolve into something that is effectively a global variable that's prettier. Like they just slather lipstick on a global variable and say, oh, it's great now. Yep. It's not supposed to do that. If you look at the original Gang of Four design patterns, that's not really the intent, but that's how it works out in practice in my experience.
Yeah, that makes sense.
Now, you used the sample of the President of the United States.
Yes, that's the example that I found in the literature.
Right. And, of course, the idea of a singleton is, it's a way to access an object without having to instantiate. That's like the window object in JavaScript. But, you were talking about the President of the United States, and
there can only be one president at a time.
At a time. But a singleton object can only be one president. So it's more like
a king?
Not even a king, because kings pass on.
A god?
Depends on which particular mythology. Like this is why this is hard, is because the president is the only president for a scope of 4 years, and then for another scope of 4 years, maybe, right? But they can also go out of scope. They have historically gone out of scope, sometimes early. So they're not a singleton. They're singleton to a scope, which is a little bit different, I guess. Effectively you go, hey, president, whatever. And okay, that's fine. I refer to the president in a single
Well, that
term.
makes sense because former presidents are still called Mr. President.
Yes. So that's why that pattern was not quite on point. And it's also why I couldn't come up with anything else, because in the real world, singletons don't exist, which is why I'm not particularly fond of this pattern, is because I don't find a great deal of usefulness in the model.
For those of you guys that are interested in our, I guess, design pattern for our episodes, you just got a little taste of it, because what usually happens is one of us will write up the outline and then we'll sit and discuss it before the episode.
Yeah. And then whoever wrote the outline will usually be like halfway through the episode and they'll be like, oh man, that's not a good way to put that. So let's just wing it.
Yeah.
Which is what just happened. But that's totally okay. Yeah. Anyway, so that's a singleton. It's a calling convention that says, hey, executable, hang something off of you that I can get to from anywhere. So it's a single address. Okay. It's a pointer that everybody has, or has access to. There's not really, like I said, this is not something that exists in nature.
There's one Earth.
Well, yeah, there's one Earth and there's one, there is one Earth, but in an infinite universe, how do you know there's not two?
Well, there may be two habitable planets, but there's only one Earth.
No, but if it's an infinite universe, there could be another planet with two dudes sitting around microphones somewhere at exactly the same time as us. Like, the reason Singleton works...
They have beards.
Yeah, but the reason Singleton works is because it is scoped.
Yeah.
Not because it's, hey, there's one. Mm-hmm. Right. It's understood to be an abstraction of...
It goes back to what you were saying about, even with the JavaScript example, for that page, there's a window.
Yeah, for the next page.
The next page is another window.
Yeah. So there's no such thing as a truly global singleton. It's a singleton within a scope because, by the way, our programs are not going to reflect reality, because if they did, there wouldn't be any singleton pattern. Yeah. But it still is a very useful pattern because it cuts a lot of junk. It's like, I don't need to instantiate this thing. I'm going to call it whatever. This happens with things that you hang off the window object in JavaScript too. Mm-hmm. Like, that's where you put your singletons.
Yeah.
Or that's where a lot of people do. And there's some problems with that too, but that's another thing. So the next one, the prototype pattern. And I guess the way to think about this is it's sort of like if you build, it's like an industrial prototype, right? You build one and then you use that to make the others.
Yes.
Although they don't really do that.
It's a fully initialized instance to be copied or cloned.
Yes. And the typical way I've seen this happen is where if, like, let's say it takes a lot of computation to produce an instance, and then you want to mutate state on that instance. Well, obviously you don't want to create another one and go through that again. And if you have basically a copy constructor, you have some means of cloning one into another one where it just moves the results over, and then you can change one or two of them in the copy.
Yeah. That's
where I see a lot of this happen. And that typically has to do with the cost of construction.
It's creating duplicate objects while keeping performance in mind.
Yes.
Now,
well, the other thing too is that prototype object, it may come out of a factory or a singleton that is responsible for going out and building all the pieces and then getting it. And then you go, okay, I don't want to go through that again. So now that I have it, alter it.
That makes sense.
Make copies.
So how is this different from copy and paste code?
Well, you're not copying and pasting any code. You're taking a object that you retrieved in some manner, and then you are copying that object in memory. It's like you're taking like a JSON object, and copying it. Well, okay,
and altering certain settings in it for
whatever you're doing. Like, let's say that parsing JSON was massively painful, or let's say it's XML, right? You got a blob of XML that's 50 kilobytes, right? But it's not just straight up XML, because in between the tags, there's encryption and there's packed bits and there's, basically all the things that people say there be dragons in programming. Like everybody took, the worst thing, and they built this document that's awful to parse.
Okay.
You parse one and you get it into an object. And let's say that you need to write 500 of these. Okay. Let's say it's an academic record for a kid in school, and then it's also got demographic information, but then packed in there is a whole bunch of stuff that was, about the school. It's cryptographic signatures. It's all this other stuff that's packed in there because it's a full document. Well, you might just create one and then overwrite the pieces that you need and then serialize those back out to make a whole bunch of documents.
Okay, I think I can follow you on that.
It's sort of like a template. It's actually probably a smarter way to put that.
You say template and it clicks.
Yeah, the template, it's a filled in template that you go, hey, I'm going to white out these pieces and write over it.
Gotcha.
Actually, best sample.
Okay.
A secretary in the 50s types up a letter.
Okay, guys, you can't see it, but he's actually like two-finger typing.
Let's put this actually a little bit forward, because I think the copy machine didn't really come out until the 60s.
All right.
But let's say you have somebody and they type a letter, right? And it's got blanks. and they fill in somebody's name in there. Well, what happens when they make a copy of it for backup, right? So they have a copy on hand. They go, oh, I need that same contract again. Well, what do? Do you type another one, or do you pull one out of the drawer, hit it with a whiteout over the places you need to hit, and then type back in?
Gotcha. Yeah.
That's what this pattern is.
Okay, so
because construction of the object is expensive, but alteration is cheap.
Okay, so let me put this in terms that I can understand. When I was doing my graduate practicum, we had to interview various types of patients. So we had the 911 responders. I know I've talked about this before. We had the patient referrals from local physician or local psychiatrists, and then we had the court ordered.
Okay.
All right. Each one had a different type of interview. Now, the 911 responders, we had a form that we had to fill out because it was very straightforward. But the others, there was nothing like that. Each one was very similar. Like each physician referral, we asked similar questions, but there was no form. And so one of the things that I did while I was there was I codified that. And I created a document that we could print out for each type of client or patient that we saw. So that was a prototype.
Yeah, that's effectively what it is. So it just has to do with the fact that the cost of construction is high. And the other thing too is like if you've what I said was a template. A prototype would be how we wrote the reports, because we took the last report we wrote and we went in and we changed, because a lot of the stuff is the same. Like, you talk about the test and its validity and stuff. That's going to be the same no matter who's taking it. The test data is still the same. The test validity is still the same. You just got to go in there and change the scores and the interpretation. Yeah.
So we would take the last one we wrote and then go in and change that. That's how they were doing it when I started. When I left, we had a template so that we didn't accidentally put wrong patient information in there. Honestly, I got a lot of thanks for doing that, and that was only because I was there 30 minutes early every day and bored.
Yeah, well, it works.
Yeah,
but that's what that design pattern is, and this does exist in nature because mitotic cell division is like that. It's like, hey, I've got one, but that one's a little bit different because the cell itself is the one invoking the copy.
Yeah.
So like the cell division might not be necessarily a prototype pattern, but your DNA is a prototype pattern, right? Because something's going to run down it basically and make a copy during that mitotic cell division. It starts out, with the initial template and then spits the other one out.
Yeah.
Now, what happens during that division is you do get mutation.
Yeah.
There's a background level of mutation that will happen. There's mistakes. There's all that kind of stuff. It's not quite an intentional templating mechanism because there's supposed to be error correction to keep it from happening, but effectively it works out like a prototype pattern.
Yeah, that makes sense.
With a very light very small deviation of change.
Well, that's how we get variation.
Yes.
In the species.
Yeah, it's imperfect. It's a bad copy.
Yeah. So next we have the builder pattern, and this separates the object construction from its representation.
Yes.
And it builds complex objects out of simpler objects.
Yeah, and I guess the idea here is a builder object would be, or typically what I see with this is things that are sort of declarative. So it wouldn't be like it's not like you're giving the object a recipe, but you're saying it's actually like driving up to a Burger King window and be like, hey, give me a double Whopper with cheese and da-da-da-da. Like, you're not telling them how to cook the burger. You're saying with this. Here's all the components. You'll actually see that sort of pattern kind of works out in fast food a lot. Like that's a very easy sample for people to get.
Yeah. Well, the example that I found had to do with a kids menu in fast food, and almost any fast food restaurant you go to, they're going to have the same format, but the kids menu is a main item, a side item, a drink, and a toy.
Yep.
And, you go up and you order, you say, I want a kid's meal with the cheeseburger, fries, and a toy for a girl.
Yeah.
And, they know you're not telling them how to make those items. They have a set list of items. And
and you're also just telling it really, you're really just telling them how what you want varies from the default.
Yes.
So it's convention over configuration.
Yeah.
You're just configuring the pieces that you need.
Exactly.
That's typically what you see with a builder pattern is, okay, there's a default way to create this, but there's overrides for the pieces I really care about. And other than that, I don't want to be involved in the creation of that object. Like, I'm not going back there and harassing the fry cook.
Yeah, exactly. No. Next, we have an object pool, which basically recycles objects that are no longer in use. This can be a performance boost when the cost to initialize a class is high.
Yeah, and a good example of this is a database connection, because this is a place where you use pooling all the time.
All right.
And the idea is like, okay, I have a web app, and let's say that it's, when it starts up, it starts opening database connections. Those take time, right? Because it's got to talk to the server and go, hey, are you there? And the server goes, yeah, I'm here. Goes, hey, can you do this for me? It says, yeah, I do this for you. Here's your, and it goes, there's a big handshake going back and forth over the wire.
Yeah. Once
you have that object that's basically an open connection, you do your thing on it. If you release that object, the next guy that comes along that has to do something has to go through that same process. Whereas if you put the object, you say, hey, it's released as far as I'm concerned. Like, I'm not holding a pointer to it, but I'm going to put it over here in the pool, and somebody that wants one can ask the pool for it.
So all that stuff is already done, and they just grab one. I get that. See,
instead of pulling a brand new wire and then connecting it, they're just touching a hot wire.
Yeah. Okay. See, the example that I had, the non-coding example, I guess, is an office warehouse. So when you have a new employee that starts working at a place, they need their workspace and their equipment. So you go to the warehouse and you take the equipment from the warehouse that you need, and if that doesn't have all the equipment, you go and order it. Then when an employee leaves, either they're fired or they get a better job somewhere else, whatever,
or they graduate. Isn't that what Instagram calls it? When they let somebody go, they graduated.
Really?
Yeah.
All these Silicon Valley places.
Yeah, they come up with words for things that aren't. But basically, the idea is
then you return it back. You return that equipment back to the warehouse so that the next new employee that comes in, you can go to that pool, that warehouse.
Yeah, you basically are having a stock or inventory of objects that you're working on.
I mean, a good term for this would be an object warehouse.
Yeah, well, warehouse has got other connotations in programming, though, because people think of data warehouse.
Okay.
So it's more, that's the deal with a pool. It's just like, hey, grab one out of the pool.
See, I think of pool and I think diving boards.
Yeah, well, that's what it's been called for a very long time, and you'll see this a lot of places where you have to maintain an open connection to something. A socket, any kind of network connection, that sort of thing, or some object that really takes a lot of effort to create and is not stateful.
Yeah.
Not really stateful. That's not a good way to put it. If the object, when it's done with, you can reset it to a state where it's usable again, and it's expensive to create, you tend to pool it just to hang on to that instead of rebuilding it. And usually, pooling comes with policies. So, like for instance, with SQL connection pooling, right? It'll go, okay, do I have one? If not, create one. And then hand it to them, and keep the reference in the pool. And then when they release their reference to it, I still have it.
That makes sense.
And then you'll have a limit, right? So you'll say, okay, I want to create this many connections. Now, I've seen this done a couple different ways. It's like, I want to create this many connections by default, and go ahead and have them in the pool.
Yeah.
So that as soon as something calls it, it's good to go, because you can spin those up async.
Okay.
Or you'll see a thing where it's like, hey, when it hits the pool and says, I need a connection, go get one, but then keep it after that.
Yeah.
Now, pooling, an object pool also has a particularly interesting problem that occurs.
Okay.
And that problem is what happens when the object has state. I'll give you an example. A database connection. My app says, yo, connection pool, give me this database connection. I get the connection, I do my thing, I close the connection, and I hand it back to the pool. What happens to the next guy? Connection's closed. He says, oh, the pool gave me an open connection. I try to write to it. Nope. So most of the time this involves a layer of indirection that says, hey, am I in a pool? In other words, does the object know about the object typically will know about its pool and say, okay, if they try to close me and I'm in a pool, don't really close.
Yeah.
And so you do have to kind of be aware of that, because this is shared global state, and it has to be managed appropriately.
Okay.
You also have a lot of very interesting threading issues, because let's say that you have 20 database connections and you have 40 threads kicking off. Well, the first 20 get those database connections. What do the other 20 do? Do they go, hey, do you have a connection? Oh, if you don't, then let's do something else. Or do they go and just hang there and wait? Because then you end up with thread pool starvation. So
yeah.
A lot of these patterns you have to be kind of careful with, because of the fact that it's intimately tied into the flow of whatever's accessing them. Singletons typically will be thread safe, at least in .NET if you're doing that. Prototypes, right? Part of the deal is okay, I've got an initial object and I want to clone it, right? But if everything has access to that object, or if multiple things do, and I clone it, but there's this one goober that wrote to it, that's not good.
Yeah.
But this especially comes out with pooling.
Mm-hmm.
That's a pretty good way to put it. It's just basically, hey, this is expensive to create, so we create them and we keep them here, and people can check them out. Or it's like library books.
Oh,
that's actually another.
That's a
physical pattern for pooling. It's effectively a community saying, hey, we want to have, I don't know, Dante's Inferno.
Good book. You read it?
Yeah. And we want to have that book. But we don't want everybody in town to buy one, because that's expensive, especially if they're only going to read it once in high school.
Yeah.
Right.
Yeah.
So we keep one at the library, and when somebody needs one, they go get it.
Except for my high school, where we had to buy the book anyways, but
Yeah. Well, and so you saw the resource problem there. But what do you have? You have a place where the objects are stored. You have a consumer that goes and gets the object. Now it's not in the pool. You have the ability for the object to be damaged.
Yes.
Or otherwise irreparably altered while outside the pool. You also have the possibility that somebody's not going to turn the book back in, which also happens with connection pooling, where somebody never closes the connection and your connection pool gets starved.
Yeah.
You also have them having to return it when they're done, so that somebody else can use it. So think of it as almost a library for your object. What
would be the fee for returning it late?
A crash server, potentially. Because instead of...
That's good.
I guess think about it like this. It's almost like the library borrows the book from another library. Now the library has a problem.
Interlibrary loan.
Right.
Use that.
So think about it. Think about it like that, and the pattern starts to make a whole lot more sense, because it's a way of saying, "Hey, here's a resource that we don't use continually, but we need it on hand for everybody."
Yeah,
it's subject to the tragedy of the commons. However,
yeah, that makes sense. So our final pattern in the creational design patterns is the abstract factory.
Yes.
This is a super factory that creates other factories.
Yes. And the reason you're doing this is, and this is down the rabbit hole a little bit, right?
Yeah.
Let's say that you had a factory pattern for creating whatever, but later on you want to actually change that factory out. But now your code has got cohesion to that. Okay, so what an abstract factory does is it says, hey, I have an object here that says, give me a factory for this other type. And it'll go find you a factory and hand it back to you, so that your code is not tied to it. However, now your code is tied to the abstract factory.
Yeah, okay.
And so you can now see the rabbit hole that people make fun of Java, even though they're maybe not even the worst offenders about this anymore.
Yeah.
Because... okay, now the next thing is, well, now I'm tied to the abstract factory. What do I do? Well, I have an abstract factory.
We talked about that.
Yeah, like that's a running joke, but you'd be surprised how frequently that sort of thing happens, because stuff gets changed.
Okay.
But the idea is, now instead of being decoupled from the object that I'm trying to construct, I want to be decoupled from the object with which I'm trying to construct that object.
Well, it seems like you're going to be coupled with something.
You are.
At some level in order to get anything done, really. And each of these tends to just be the next level up.
Yeah. Well, any pattern that you use because it's advantageous in that context.
Yeah.
Right. I mean, there's a certain level where your app gets big enough that you're going to want, you're going to want actually to be able to separate that out and get yet another level of indirection.
So to get a good understanding, before we kind of get into talking about patterns and stuff, but to get a good understanding of the abstract factory, I do want to give this example of a car factory. So you have one car, you're building a Ford F-150 or a Nissan Titan, because we live in Tennessee and we've got a big Nissan plant in Smyrna where I grew up. But you have one vehicle, but there are many different door models that will fit that one vehicle. So you have factories that make the different doors. You have many different wheel models that will fit that vehicle. So you have factories that make many different wheels.
And then what do you have? When you have a bill of materials for building a car, you go, hey, here's the pieces.
Yeah.
I don't care how they get here.
Exactly.
Right? I'm decoupled from the factory that is producing those things. Mm-hmm. So I send it through a layer of indirection and say, hey, get me one of these wheels. That thing then goes and says, okay, where's the factory that does this?
Might I suggest you get 4 of those wheels? Just a thing.
Yeah.
Sorry.
It's a good idea, but effectively what you're wanting to do is to decouple the construction of your object from the code that is constructing it, so that if that changes, you don't have problems. Either the object changes itself, or the way that you have to invoke that object changes, or you want to replace it with a completely different implementation, right? That's where you would use the factory pattern. But then now you're tied to that factory as well. And if you're doing enough stuff at a high enough level, you may want to actually step back yet another level from that, just to get away from it.
Makes sense. So to review, we talked about the creational design patterns. These are the ones that are used to create objects. That is the factory method, the singleton, the prototype, builder, object pool, and finally, everyone's favorite, the abstract factory. So with that said, before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, since we had the conversation about object creation and the whole pooling thing, I figured I would just run off from there, completely off the outline, so that you're surprised. So let's talk a little bit about the scope of objects.
Okay.
Now, let's say that you have an object. How long should you retain a reference to an object? In other words, how long should that object exist? If you're doing a garbage collected language, obviously it would be like I get rid of the reference and something behind the scenes gets rid of it. Whereas if you're doing C++, you got to say, hey, delete it. Right? But how long?
Till you don't need it anymore?
Okay, so when do you create the object?
When you need it.
There you go. The lifetime of an object should be as long as it needs to be, no longer. And the reason this is important is I see a lot of code where somebody will have this massive process that, writes one record to the database, but the first thing they do is they open the database connection, and then they go through 30 seconds of processing, and then they cram something into the database that's like one record.
Well, they don't need
yeah, you should be doing it as close to the place where it is needed as possible, and releasing as soon after as possible. This is true with, now, of course, if you think you may need it again, obviously you use a pattern like an object pool to hang on to it. But this comes in when you have an object pool as well, because you don't want to pull things out of the object pool before you actually need them. And the reason this is important is because you will cause pool starvation if you're not actually using the thing. You want to get it out, do what you got to do with it, and then let it go. And so this is very important as far as object lifetime, because this is how you write tight, efficient code. You don't create things before you need them, unless, with the possible exception of creating them async and then getting it later while doing other work. And you want to release resources as quickly as you can, especially if it's a resource that is very limited. So things like open sockets, things like in windows, like you're drawing context on an actual window. A lot of those objects are unmanaged. The operating system gives you a certain number, and then past that you can't open anymore. File streams tend to be this way as well. And so the idea is that get it right before you need it and let go of it as soon as you can. And that will help your app scale and hold up under more load. And that's all I've got. If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.